Hello? Hello. Should we start? How's everybody doing? Hi, Vancouver. It's really good to be here. I miss this place. I'm from here. All right, let's get into it. You probably want lunch. My name is Brian. I split my time between here and San Francisco. Co-founder of a company called Begin. I have probably a little bit more notoriety for working on a thing called PhoneGap, but I don't do that anymore. These days I'm doing serverless stuff. And this is one of my favorite quotes as it pertains to software development, because I think it's super true, especially when you think about your dependency tree. So I used to do this. I used to rack physical servers in a different time. And we would get a box, and we would open that box up, and then we would like shove this thing on a rack, and then we'd plug a bunch of cables in. We wouldn't label anything. And then we'd need to scale. So we'd get another box, and we'd plug that in. And that worked for a really long time. And then virtual machines kind of became a thing. And this rapidly changed how we were able to provision stuff. We were able to get ourselves into more problems way faster than before. And that was pretty great. But virtual machines are kind of slow. So physical machines didn't scale very well horizontally, or rather vertically. So we started to use lots of commodity servers. And virtual machines kind of became their own special hell. And very recently, we have the concept of containers, which you are all probably familiar with, Docker and Kubernetes. And they give you a fast startup time. And they kind of fix some of the problems that we had dealing with virtual machines. There appears to be an ever-tightening cycle of how we deploy stuff. And Cloud Functions are the latest iteration of this idea. And if you take anything from this talk today, I want you to think about how Cloud Functions are a totally different metaphor than a physical server. So we've been doing this a while, a long while. We just started doing this. And I would like to propose that we still don't know what the fuck we're doing, but we're getting better at it. And it's created its own problems, because it's a different type of solution. The nice thing about Cloud Functions is you can deploy them really quickly. Another nice thing about Cloud Functions like Lambda is that they're effectively free. You get 1 million executions a month for free. The second million executions is a dime. So if you're doing 10 million executions a month, it's 90 cents. So those are pretty good unit economics. But it's not to say that free is so interesting, or not as interesting to me, but the isolation is interesting. So instead of your application having a single monolithic ball that can break, you split things up into these individual little functions, and you have this high degree of isolation. So now when you do a change to one part of your app, the other part of the app doesn't fall down. So Cloud Functions are a totally different metaphor. That's interesting, and we, maybe stupidly, possibly at the risk of my own startup, decided that this is where things are going to go. So we're going there right now. And this was about 1.5 years ago that I decided we would move our entire infrastructure over, because we're building a bot on Slack, and we think that this thing is really well suited to that type of thing. As we did the thing that you would always do. So when we started building our stuff, we built a web server, and we deployed that in a single Cloud Function. And it worked really great, like really well actually, until our functions started to actually have some logic beyond hello world. So Lambda functions in general, and functions, as they get bigger, they start to exhibit properties that are not optimal. They have cold start times that are really slow. They become difficult to deploy because they get really big, and it's just not the way that it should be built. So we started to separate our functions out by, basically route, and things got really good. But one of our problems is that things got really complex. And so now for every route, we had a function, which you do logically in your architecture, but that means that for every route in our application, we also had to deploy them individually. And we had to set them up individually, and we had to add environment variables to each one individually. And it got really difficult to manage. And when things get difficult to manage and you're doing it manually, you end up with checklists. Things get out of sync. It gets really hard to reproduce your environments. Bugs happen. People get mad. You're up all night trying to figure out what went wrong. Another big issue going this way, when we came into the room, I've been working with Amazon for a very long time. So this view of AWS does not terrify me as much as it should. I totally don't know what half of these things do. And I think most people are the same way. When you go and land on AWS, you're like, okay, cool. Let's go, build something. I don't know. There's just a lot of stuff. And that cognitive overhead comes with its own cost. You can't really know what you're going to build until you know how to build it, which would, kind of lead you to the thinking that you would have to master this whole thing to build something, and that's really not the case. So we solved most of these problems in the last generation of metaphors with servers, and we called that thing infrastructure as code. And the manifestation of infrastructure of code effectively is that you check in a manifest file into your repo, and you conversion your infrastructure. In that manifest file, you run some commands against it, and it does its thing. There's a whole bunch of tools that do this, but they all basically work the same way. So you have this manifest file in the root of your repo. It can be an Ansible, it could be Docker, it could be whatever, and then you have some kind of global CLI binary that you run against it to recreate your business. These things did not exist when we started, and had they, I may not have giving this talk right now. But these things exist now, and so I think it's important that you know that these things are ways to do infrastructure as code with cloud functions. And I think this will also help you understand why Architect from JSF is possibly a nicer way to work. So Terraform is from a company called HashiCorp. They're famous for a thing called Vagrant, and it's getting quite a bit of popularity. It's a manifest file, you run against it, it creates and provisions infrastructure for you on the cloud. Serverless framework, the capital S serverless framework, is a venture-backed company. They have a manifest file, you run some stuff against it, it generates infrastructure. Amazon didn't want to be left out of the party, so they created their own thing. They call it SAM, which stands for Serverless Application Model. Yeah, and it does the same thing. So let's take a look at these manifest files. Terraform created a thing called HCL. I assume that's because their sponsoring company is HashiCorp. This is an unkind example deliberately. So this provisions a single Lambda function. And you can see they've created their own little sort of language where you've got like a key value thing going on. It's got braces, and you can nest JSON strings. It's not too bad, I think. Once you understand what this is doing, it's not awful. And if you check this into the root of your repo, anyone on your team would be able to create that Lambda function, and you'd be off to the races. I don't think you'd write this by hand. I don't think you would write this from memory. You'd probably be looking stuff up and copy and pasting. But that's okay. It's a way of doing things. Serverless, I think, took inspiration from Ansible, because they decided to go with YAML. YAML's fine. It's another format. It has significant white space, which I don't particularly love, because if you're missing one of these spaces, you're fucked, and you'll never find that bug. But so this provisions a couple of Lambdas in a DynamoDB table. Again, there is a great deal of inside knowledge required to write this file. You would not write this file by hand, probably. But it's powerful. This idea is really great. If this is checked into the repo, again, anyone can provision these Lambdas without having to go into the AWS console and poke around at a UI. Amazon didn't want to be left out of the party, and they really liked the term serverless. I don't think they liked that serverless got a trademark for serverless, but so they created SAM, and it's based on their internal infrastructure as code, which is called CloudFormation. And I actually really like CloudFormation. I think it's a brilliant product. It too, unfortunately, has chosen YAML. One thing on this screen to note, this is how far ahead Amazon is than everybody else, and they like to show this off. They've been doing this stuff since 2010, and I think that's hugely impressive. But they didn't do any of this serverless stuff until well into 2016, and so this is pretty new. It, to me, looks a lot like serverless, except for it's their serverless, not serverless is serverless. Serverless is kind of neat because it can run on multiple clouds. Obviously, AWS SAM only runs on Amazon's. The other comments or problems I have with this format are similar. Like you have to you have to know a lot of stuff to be able to write this file, and you probably won't know that stuff off the top of your head. And if it's missing a space here, good luck finding it. So to summarize my exceptions to these assertions, I think you need deep proprietary knowledge to understand how to configure and set up really basic stuff. And that's okay, but it's a thing. I'm not a huge fan of hand authoring YAML or JSON. I think some people might be, and that's okay. It's not for me. It's missing comments. It's got bad characteristics for bug resolution if you have an extra space. And I feel like most of this tooling kind of smells a lot like servers, and I'm over it. We're not doing that metaphor anymore. We're thinking about things differently now. Functions are the metaphor. And so I kind of think that we're actually committing AWS infra configuration arcana into our revision control systems, which is kind of like committing a build artifact into your revision control system. And we already know that's a bad idea. So we've traded one set of problems for a new set of problems. And they're not bad problems, but they're there. So what Architect proposes is infrastructure as code was a really great metaphor for servers, but we want to put forward the idea of architecture as text. And so we've defined a manifest format that's a little bit more chilled out. The manifest file is called .arc, so it's not in your face. It's just a hidden file in the root of your repo. And it looks like this. So I'm going to explain these little bits here. So to understand Arc, first of all, comments start with a pound sign. Sections start with an @ sign. And everything after a section becomes infrastructure. So in this Arc file example, we have an app namespace, hello app. So all the infrastructure that gets generated will be prefixed with hello app. And then we're defining a single HTML route at the index. And the other thing to note about Arc is it uses NPM scripts for its tooling. There's no global CLI binary to install, and this is a really big deal. I don't know why we didn't learn this lesson with Grunt, but having a npm install -g means that you only have one version of that thing, which means if you have two projects, and if you had two serverless projects and they're two different versions, you're fucked. So npm scripts get around that. You can have multiple versions of different projects and just work without having to worry about that. So if we run npm run create against that Arc file, our get index will generate this single function, and it'll deploy it. And an Arc file becomes very expressive after a little bit of time. If I run npm run create against this Arc file, it'll generate this folder structure, which anybody can understand what's going on there pretty quickly. You can see the HTTP verb, and we can see what content type it's dealing with. This would be a complete Arc file. There's all kinds of functions out there, and there's more every day, and it excites me. But these are the basic ones that we support today. HTML routes, JSON routes, events with SNS, scheduled CloudWatch functions, which is a fancy way to say cron jobs for functions. Tables in DynamoDB. I'm a huge fan of DynamoDB, and includes the ability to run triggers on updates or inserts and deletes. So let's take a quick look at the generated code. And actually, maybe this is a good time to just start writing some code. What could possibly go wrong? So I'm on my desktop. Can everybody read that back there? Yeah? You're good? Okay, cool. So I'm going to make a project. Call it like what? And I'm going to npm init it. So that just created a package JSON file. And I'm going to install Architect workflows. I'm going to save that. Arguably, I could save this as a dev dependency, but just a demo. One thing to note, Arc is, I call it Arc, which is kind of weird maybe, but Arc is running on node 6.10 with the default npm install. it's not because I like that, it's because that's what Amazon forces us to use with Lambdas, and I am disinterested in trying to repackage Node inside of AWS, so it takes a second to install, but we're there. So I'm still here, nothing there, just some packages. I'm gonna touch an arc file, which is just a text file. I'm gonna edit it. I'm gonna give it a name, what, and we'll just add a single HTML route. I'll jump over to my package JSON. I'll add that create script. So this is kind of weird. People don't like this. Amazon uses environment variables to dictate which Amazon account you're using and which region or data center that you want to deploy to. I have multiple Amazon accounts. It's kind of a thing that happens. So I'm just going to use my personal one. I'm going to add another script here. Whoops. Deploy. Deploy. Well, let's run it. So this isn't as fast as I'd like it to be. Oh, that's funny. I created this morning. So some of these tables already existed. One thing to note about Arc, if something exists, it just skips. So it never deletes anything. And so if you want to delete infrastructure, be my guest. We're not going to do that programmatically. I don't want to automate destroying your Amazon. So that would be a bad thing. There is a downside to all this, though, in that you end up with a lot of functions. So we built that little hello world, and we deployed it. And now subsequent deploys are going to be a lot faster. So let's take a very quick look at that generated code. This is maybe not the most popular opinion, but I'm a huge fan of Express. So we cloned Express's API, but not perfectly. And we did that on purpose. So you have a request object and you have a response function that you invoke with a named parameter for what you want it to do. That way it's kind of React-y. So I'm going to upgrade my function. I'm fucking stoked that Node Interactive's in Vancouver, by the way. There was never cool conferences here when I was living here as a developer. Okay, so, oh, actually that was a good typo. A. People are always like, you're Canadian, eh? That's what happens. So I'm going to deploy that. And we're done. That's kind of amazing, right? Like, we just stood up a website and redeployed to it in how long? Two seconds. That's actually kind of slow. So this is also something you might notice it's neat. We deployed twice. So Arc, it's cheap, right? It's like a buck for 10 million executions. So we create 2 Lambda functions for every logical component of your application, one for production and one for staging. And the deploy process is completely isolated. So I've got my staging Lambda here. Let's upgrade my production Lambda now. The production Lambda, I decided to make an environment variable where you say arc deploy production, npm run deploy. And the reason I made it an environment variable is because they're hard to type. So you think about it. So you don't want to accidentally deploy, but there you go. So now we just upgraded production. Let's add another route, just to make things fun so you can get a sense of the iterative nature of this. Let's add a JSON route for giggles. So remember, you can just keep running npm run create. You don't have to worry about it clobbering something. It will only create stuff if it doesn't already exist. And so we've encountered that we have a Lambda here that we need to create, and we're going to create it, and it's going to walk the rest of the arc file and ensure that all the assets are there for that. API gateway gets rate limited pretty aggressively, and I guess this is a feature. So Amazon doesn't want you standing up and tearing down APIs every second. So they actually rate limit you to, you can only delete one API a minute. This has turned into a fairly big pain in my ass. But yeah, so it takes a second to create the infrastructure. Once it's created, obviously, the subsequent deploys are in the seconds, which is kind of nice, but this part's a little bit painful. So great, we deployed, and now if I go to my staging API, I get some, I get forbidden JSON? That's funny. Is that what I called it? API? Whoa, Firefox, what's up? Oh my God. Thank you. Huh. Hold on. Let's see. Staging / API. There it is. I think I might have actually beat it to the deploy there. I'm not sure. All right, well, let's take a look at that JSON Lambda that we just generated. So again, very expressy. We just send back some JSON, like, hi. And this is kind of fun. Arc deploy does not get slower as you add stuff, because it spawns processes and does them in parallel. So you can have as many lambdas as you want. The deploy is still going to be a couple seconds. And so we're live with our API endpoint. That's a pretty good start to understanding the benefit. This is an infinitely scalable endpoint that will never go away. That cost me less than $1 a month for 10 million executions. It's not bad work for the last 5 minutes. I'm fairly pleased with that level of productivity for me. So you got a sense of the HTML and the JSON world. Arc supports gets and posts. It supports redirects. It comes with sessions built in by default. I ripped off all of IBM's hard work on the crypto inside of Express, so you can rest assured that I probably didn't mess it up. Arc also supports SNS events. SNS events are effectively pub/sub lambdas. These are great for doing background processing or you know, things that you want to do that might take a little while and you still want to get back to the user. We use these in our bot pretty extensively for begin. And I don't know if I should show you this, so I'm going to show it to you anyways. So this is the secret sauce behind our bot. We've built a Slack bot that lets you do tasking inside of Slack. And I think this is kind of an interesting thing about Arc. An interesting side effect is that everybody in this room can read this file and they kind of understand how our bot works, which is amazing. I don't think you would get that same property out of reading a gigantic YAML file or a gigantic HCL file. Yeah, so events, oh yeah, that's why I went over here. So our bot is, you know, it's a real-time bot, so it deals with a lot of events. And we found that we actually have very few HTML lambda, but quite a few event lambdas. We were very happy with the performance there. Our bot usually responds within 200 milliseconds. We also do a fair number of these cron jobs or daily notification type things. And if you look down here, you can see them. Cron syntax is not the kindest, but this effectively would generate 2 Lambda functions that would run on that schedule. You never need to set up a server again to do a cron job, which opens up the world of a lot of possibilities. I've got one that checks hockey scores in my pool, coincidentally. It's sad because I'm a Canucks fan. I'm still not over it. Yeah, we also do triggers. I remember when I was a younger programmer, database triggers were bad, but they're back and they're good. Because you don't have to write them in SQL, you can now write them in JavaScript. These are DynamoDB triggers, and so now anytime this particular table I'm subscribed to does an update, I can do something like back it up, I could mutate the data, I could ensure some kind of integrity. When we added a row to our accounts table, we shoot off an email using a trigger to say welcome. So they're really useful. They're really handy. And that's actually about it for Arc. So you declaratively define your architecture. high-level primitives in an ARC file, not any AWS configuration arcana, just plain old text that anybody can read. There's workflows that are NPM script-based that are local to your code and do all the configuration and provisioning. And then, of course, there's the cloud function wrappers themselves. Oh, yeah, that's right. It's funny, I added this later. So NPM start, you can run offline. This was a issue for us. You know, when we initially started building our thing, we actually it deployed so fast, we didn't really miss working offline. But one of our team members lives in Oakland, and he's got to take the BART, which stands for Bay Area Rapid Transit. It's like a ironic name because there's nothing rapid about it. But anyways, he kept saying, dude, get this thing running offline. So we did. I use node.env for this pretty extensively. It's maybe, well, I think it's a good thing. You still set up your region because Arc expects it, and you still set up your profile because Amazon expects it. And then it's Arc sandbox. Oh, is my region broken? Oh, yeah. I don't know if it would complain. I wonder. Thanks, Chris. So now npm start will run our application offline. In theory, you could use this to run this thing in Zeit or somewhere else, but now you have completely negated the benefits of the cloud. So I don't know why you'd want to do that, but if you did want to do it, you could, and you can, do your development all on localhost and then deploy when you feel like it or when you get off the BART or whatever. So that works. That's pretty cool. By default, we always just deploy to staging, so that there's no fat fingering to production by mistake. And then Arc deploy production is, a little bit tricky to do. We actually don't deploy locally very often now. Most of this stuff we just hid behind our CI system, and so check-ins are just constantly deploying to staging. And then when we, feel brave enough, we'll promote stuff to production, which is usually a couple times a day. And that actually, to me, is the big thing about Cloud Functions. So it's not the cost. It's the deploy speed is the big deal. A rolling deploy of servers can take a long time, especially if you have sticky sessions. You can look at like 45 minutes for just 3 servers to swap over. Rolling deploy on AWS with Lambda functions for us with about, well, let's see. I want to see what we're at. Oh, hey, this is a great hack. Did you know 1Password supports OTP? It fucking changed my life. Anyway, so we are running deploys like all day long, but one of the problems of making it easy to create Cloud Functions is you end up with a lot of these things. Some of them we're not deploying all the time, apparently. Some of them we are. These things go, I don't think we have a deployment that runs any longer than a minute, which is a pretty big deal compared to how it used to be back in the day. PhoneGap build, by comparison, would take hours for us to roll a deployment. But it was a Rails app, so I think that's how they work. This whole thing is open source. So we built this with our company, but we donate it to the JS Foundation. I believe in open source governance as well as open source code. So anyone can contribute to this, and anyone can modify this, and anyone can do what they want with this. And the ARC file format is pretty simple, so you could extend it in your own ways if you chose to. And the parser is really, really dead simple. Yeah, before ARC, it used to be kind of painful. And after ARC, we're now quite happy. We're really enjoying working with Amazon and AWS. It's a bit of a shift in how you think. You're now actually architecting functions. You're not architecting servers. But once you get over that conceptual hump, things are pretty good. You can find all this stuff at this sweet domain name, arc.codes. And thanks for having me. Do we do questions here? Some conferences are weird about that. Fuck it, we're doing it. What's up? Do you have a question? Here.
This is a definitely no, but is white space important in the .arc file?
It is, actually. Yeah, we ended up, even after me complaining about it constantly, It is significant in one case, and that case is tables. Let's see if I can find an example. So tables take 2 indents, so I know what the key and or triggers are. But otherwise, white space is totally unimportant. So we strip it all, and we strip all comments when we do the arc file pass. So I guess it's not a binary yes or no, it's a sorta. It's sorta important if you're doing tables. Yes?
Do you have an example that would that be look it up in incognito or something?
To incognito, I haven't done anything with that myself. We built our own little tiny login flow on top of our session support. It's pretty darn simple. You could be like, well, I don't want to take too much time, but after this I could demo for you how I would create a login flow. I personally wouldn't use incognito, but I know some people have and they like it, and that's cool. We were trying to be as vanilla as possible because a longer term goal of this project would be to be portable across clouds. And once you use incognito, you're baked right in. I don't think that's a bad thing either, by the way. Like, people talk about this cloud lock-in thing, and it's not lock-in, it's opt-in. You're just picking your infrastructure provider. Lock-in would be like, you don't have a choice. You have choices, and you just need to make the best one for your company and your needs. Yeah? Yeah, it runs, so the question is, how do we do the debugging? I actually don't use a debugger. I know that's shocking, I don't. And it's not because I don't have bugs, I have lots. I write tests, and it's how I learn to develop my workflow. I know that if this is offline, it's running in its local state, you can totally hook up a node debugger to the process the same way you would with Express, if you want to, or if that's your style. Yep. Yeah, that works. You can't, some crazy person out there actually got Chrome Inspector working with the remote Lambdas. I haven't played with this myself because I don't use debuggers, but yeah, it's there for you if you want to do it. And it can work remotely too. Amazon, and I don't want to gloss this, the user experience for developing these things can be pretty tricky. So this is a Lambda function in all of its glory in the AWS console, and apparently this one, I don't know, it gets an email login, okay? And we have no errors apparently. I don't believe that for a second. So this is maybe gonna leak somebody's information, I don't know, but like you have to dig around logs to do your development time stuff. And CloudWatch is not the most awesome place to dig around for logs. So a lot of people are using either a tool called Honeycomb, there's another one called Humio, and they ingest these CloudWatch logs so that you can locally search structured data instead of poking around the AWS console. It's less of a problem in Arc because we have the isolated staging and production Lambdas, so it's very easy for us to reproduce a bug and then just go check out the CloudWatch logs. But some people like having more robust monitoring solutions for their production Lambdas, and I recommend that you definitely look into that. I know I want to. You can see our DynamoDB needs more provisioning. That's funny.
How far have you pushed serverless to build out infrastructure for Begin, let's say? Are you all serverless for Begin?
We have 2 servers. We have one server for our Small Wins Today website. The name of our company is Small Wins, but we ended up with begin.com as a domain, so we're not using this one really anymore. I don't actually even know how this is running, but I know there's a server for it because I tagged it in AWS. And this is funny. We have a second server, and we totally don't know what that one does. We know we started it like last year, and I'm kind of scared to turn it off because it might be doing something. But whatever it's doing, I don't know. I've been planning to get in there and figure it out. But yeah, the whole thing that we've built, and so we've built a bot for Slack and a companion website for working with that bot that does tasking on a per channel basis. And it's about 500 Lambda functions in production with about 10,000 users. And our AWS bill is a whopping $200 a month. And that's all going to Dynamo, almost all of that. But with that usage, it's cheap. People say, oh, Dynamo's really expensive, and they're right, it is, but it's still cheaper than a DBA. So, yeah. Yes?
Is it in the roadmap to include step functions?
I don't know, because I don't find writing state machines that hard. And Node has great libraries for it. And so I don't know what the use case is there. But I'm into them. Yeah, I'm down. If someone's like got a really good use case, open a bug for me and I will implement that. I'm totally into it. I'm actually a little more excited about Greengrass and Lambda at the edge and what the potential could be there. So there's these new flavors of Lambda. Greengrass runs on IoT devices, which is kind of trendy, but I think there's a lot of potential there. And then Lambda at the edge is like running Lambdas like right on CloudFront. The challenge with Lambda at edge is you only get 40 milliseconds of execution time. And 30 milliseconds of that's going to be node startup. So you got 10 milliseconds. You can do a lot of shit in 10 milliseconds, but you can't do as much shit as we're doing right now. So we're going to figure out something to do with that at some point. Okay. All right. Thanks, everybody.